Alright, here's our continuation of lesson 1.9, where we're talking about inverse functions. So in our last video, we did an informal finding of an inverse function. We defined inverse functions. We verified inverse functions, and we both graphically and algebraically, and we talked about / defined the horizontal line test. Right now we're going to talk about one-to-one functions. And the definition of that is, for one-to-one functions, is if we have a function, we'll call it f, is 1-to-1 when each value of the dependent variable corresponds to exactly one value of the independent variable. A function f has an inverse function if and only if f is 1-to-1. So this whole idea of a function being 1-to-1 really means that each x value of the function has only one y value, or one f of x value. So in our next example, I'm going to pull up a couple graphs, and we're going to utilize the vertical line test to determine if the graphs of those functions have an inverse. Alright, so here in example 4, we have two functions. In black, we have f of x is equal to x cubed minus 1, and in blue, we have f of x is equal to x squared minus 1. We're going to use the horizontal line test to determine if these functions have an inverse. So what we're going to do is I'm just going to draw a horizontal line across my graph. And if this horizontal line crosses a function only one time, then that function has an inverse. If it crosses more than one time, that function does not have an inverse. So let's look at the gray or black graph. I see that my horizontal line only ever crosses at one point. So that means f of x equals x cubed minus 1 has an inverse. And if we look at our blue graph, our horizontal line crosses in two spots, which means f of x equals x squared minus 1 does not have an inverse. That's example 4. Alright, so I'm going to give you 5 ways you can find an inverse. So finding an inverse function, which we've already talked about some of these in our last 2 videos. So the first one you can do is use the horizontal line test In fact, these aren't even ways. These are the steps I would take. We're going to use the horizontal line test to first determine if f even has an inverse. Once we've done that, what we can do if an inverse exists, if the function passes the horizontal line test, we can, in our equation, for f of x, replace f of x with y. Once we've done that, we can interchange or just switch x and y and solve for y. Once we've done that, we can replace y with our inverse symbol, so f inverse of x in our new equation. And finally, once we've done that, we're going to verify that f and f inverse, so f with that little exponent of -1, so we're verifying that they are inverse functions of each other by showing that the domain of f is equal to the range of f inverse. And really, what we're going to do that, and I guess before I even go too far, not only are we going to show that the domain of f is equal to the range of f inverse, we also have to show the range of f is equal to the domain of f inverse. How we would do that is we are going to take the composite of f and f inverse. So we're going to show that f of f inverse of x is going to give us x. And we're also going to show that f inverse of f of x is going to also give us x. If that works, we've found ourselves an inverse. So I have two more examples for you. Let's check them out. So let's look at example 5. We are going to find an inverse. So we can say find f inverse of the function we're going to find the inverse of is f of x equals 5 minus x over 3x plus 2. So I'm going to tell you right now, I did graph this. You can use a graphing calculator. Just type 5 minus x over 3x plus 2 into y equals with your graphing calculator, and it passes the horizontal line test. So it's 1 to 1. I'm going to move straight into step 2 of finding an inverse. We're going to replace f of x with y. So we're going to write y is equal to 5 minus x over 3x plus 2. And now what we're going to do is we're going to switch x and y. So we're going to say x is equal to 5 minus y over 3y plus 2. So what we're going to do next is we are going to solve for y. And to do that, we're going to multiply both sides by 3y plus 2. We're going to try and get that y out of the denominator. So on the left side of my equation, what I'm going to have, I can distribute my x to the 3y and the plus 2. We're going to have 3xy plus 2x. And on the right, we're going to have 5 minus y. And now what I'm going to do is I'm going to try to move all the terms with y to one side. So I'm going to add y to both sides. And I'm going to have then 3xy plus y plus 2x equals 5. And while I'm at it, I'm also going to move the 2x to the other side. So now I'm going to have 3xy plus y equals 5 minus 2x. I do notice now on the left side with my 3xy and y, I have a y in common. So I'm going to factor that out. I'm going to have y equals 3x plus 1 equals 5 minus 2x. And now to get y by itself, I'm going to divide both sides by 3x plus 1. Because on the left, the 3x plus 1's will cancel each other out, and I'm left with just y. And on the right, I'm going to have 5 minus 2x over 3x plus 1. So we found the inverse. We did steps 2, 3. Now we're moving on to 4. I'm going to have to erase what I have here so I can do that. So stay tuned. So now I'm going to replace y with f inverse of x. So I'm going to write f inverse of x equals 5 minus 2x over 3x plus 1. And I know I said step 5 we're going to verify the composite of f inverse and f inverse of f, that they both equal x. We're not going to do that. We're going to move straight on to our last example, example 6. So in example 6, we're going to do the same thing. We're going to find the inverse, if it exists, find f inverse of f of x equals the square root of 2x minus 3. So again, I looked at the graph and it passes the horizontal line test. You can enter the square root of 2x minus 3 into your graphing calculators if you want to verify that it passes the horizontal line test. So I'm going to start by rewriting this as y equals the square root of 2x minus 3. And now I'm going to switch my x with my y. So I'm going to have x equals the square root of 2y minus 3. And to solve for y, what we're going to need to do is square both sides. So we're going to end up with x squared equals the square root and squaring of both sides does cancel each other out. So we're going to have 2y minus 3 on the right side. And to keep solving for y, we can add 3. We're going to have x squared plus 3 equals 2y. And I see one last step. To get y by itself, we're going to divide both sides by 2. So we find y is equal to x squared plus 3 over 2. And our last step, we're going to replace y with f inverse of x. So f inverse of x is going to equal x squared plus 3 over 2. And again, we're not going to worry so much about finding the composite of f inverse and f inverse of f. We could do it. It's going to give us x. We're fine. So that actually wraps up our lesson on inverse functions. We've got one more lesson left in Chapter 1, and then we'll be done with it. So I will see you later.